Hi, this is Dave Canabran. Today we'll be talking about the functionalities and capabilities of the Statistica Enterprise platform. Then we'll also look into some of the newer features of our most recent release, version 13.2. For the modeling flow, we took the example data that was provided, which is the airline data, and broke it down into chunks and dispersed it across multiple data sources. So here you'll see that some of it is on a blob storage on Amazon S3, and then we have some of it coming in from a flat file, and then here there's some coming in from a relational database, some coming in from a data lake on Hadoop, and the openness of Statistica allows for us to bring in data from various different sources, including third-party web services. In this case, we're specifically bringing back data from the METAR weather services. METAR stands for Meteorological Terminal Aviation Routine, which is a very comprehensive weather service and which is what most aviation pilots use. And this is what we will be using for most of our modeling as well. And then we also are connecting to a web service to bring back holiday information. Specifically, we are trying to identify if national holidays make a difference to airline delays. And we can also connect to different kinds of geolocation and geocoding packages out there to bring back the latitudes and longitudes of each origin and destination airport and see if we can somehow use that in modeling or at least use it for better presentation of results in the final visualization dashboard. All of these different data sources can very easily be aligned and aggregated within Statistica. All these different data sources are now available to the query builder as data tables. So we can now very easily align and aggregate data within the graphical query builder that you're looking at here. And there's a very comprehensive tool which allows us to create queries with just drag and drops. We can even specify the type of join, whether you want a left outer join, inner join, and whatnot. You can specify groupings. You can specify criteria or where clauses. You can do subqueries, expressions, all of this within the graphical query builder. And here you'll see that as we click on this, it'll generate the query for us, which makes it really easy to align and aggregate data. Once we have the data, we can now run it through the data health check summary, which is what I call the one-stop shop for data understanding. Here, all we have to do is just select all variables and run it through the typical checks, which is checking for sparseness, checking for outliers, checking for invariance, and checking for redundancy. But the best part is not only does it run just a diagnostic report, but we can also configure it in such a way that it also applies the most appropriate statistical methods to cleanse the data. This is the result from the data health check summary. So here you'll see that it automatically breaks it down to continuous and categorical variables. It identifies specific categorical variables with more than 100 levels. It identifies the sparseness of each variable, and it also gives us an outlier detection summary. So you can go through this, or you could even look at it from a variable standpoint. So here are all the variables, and those that have some kind of issue is highlighted in red. And here you'll see that this one has redundancy, these ones have outlier problems, these ones have invariance. So with just a couple clicks, we can take care of a big chunk of the data understanding and data pre-processing steps, which, as we know, are the most time-consuming parts of any project. We saw earlier how to analyze all data using in-database. We'll now perform a by-airport analysis because it's likely that different airports have different drivers. We'll start with Chicago O'Hare. So let me now run this whole workflow in real time and we can see as it goes through all these different steps. So typically it queries the data from all those different data sources and we can go through aligning and aggregating, but here it's coming in from a simple data table. And then we subsetted only those airlines that originated from Chicago O'Hare. And then we ran it through automated variable selection, which is identifying which of these factors are the most important to help us predict airline delays. And then we're going through a typical process of breaking it down into training and testing data. And then we are running multiple different types of data mining models, specifically boosted classification trees. And then we are running it through automated neural networks and chain methods. And as we have already seen, we could very easily open this up and bring in all different kinds of models, whether they are R packages or Python modules, or pushing this to algorithmia and scoring it there, or even scoring it on Azure ML, or even bringing in some deep learning methods. Ideally, deep learning is better suited for ImageNet classification and speech recognition, but we do have deep learning methods. So here you'll see that we could throw in a deep learning classifier and build a deep neural net. Anyways, here you'll see that the modeling is now finished. So what we can do is we can now go through the results and compare these models. So here we can look at the gains chart, we can look at the lift chart, or we could look at the ROC curves, or if it makes sense, we could even assign a profit and a cost and look at profit cost charts. Let me also dig deeper into some of these results here. So here you can look at the importance plot, and it's very interesting that a lot of the different metadata that we were talking about initially for both the origin and the destination airport seems to be very important. So we can break it down by these different factors. And interestingly, the hour of day when a particular flight is scheduled to depart seems to be a very interesting fact. And this we're breaking it down by whether or not the delay is going to be greater than 15 minutes. So going through this, we can identify a lot of different factors. For example, the relative humidity of the origin airport is an interesting factor, which seems to make a significant difference to whether or not there's going to be a delay of greater than 15 minutes. Similarly, the temperature in Fahrenheit seems to make a difference as well, and so does the dew point index. The comprehensiveness of Statistica allows us to slice and dice data in all different forms. And here you'll see that we are breaking it down by unique carriers, uh, all of which originated from Chicago O'Hare. And here you'll see that Delta seems to be doing significantly better than all of the other airlines. If we go further and break it down by specific airports, which we know are some of the most traveled to from Chicago, we can still see that Delta Airlines has only a 20% probability of having a delay of greater than 15 minutes, whereas someone like United has a 33% probability, American Airlines has a 30% probability, and so on. Obviously, all of these results are made available to the end user or business user via simple, intuitive, and easy to use visual dashboards. Here we can see the same results as a visual dashboard. So here this is the result from the feature selection or the automated variable selection that we're talking about. So we can see that the hour of day or time, as well as the relative humidity, the altitude, the temperature, the dew point index, all of the different factors that we saw are highlighted here. And we can look at hour of day and see how that makes a difference. And by the way, what we're looking at here is the prediction from advanced analytic models. And we could even use this as a what if scenario generator. We can interact with these different charts. And as we interact with them, you'll see that the numbers here, which is basically the risk of delay, is being updated in real time. While we have created these models only for flights from Chicago O'Hare, we could very easily create a model for all airports. So here you'll see that rather than go through the subset, I'm connecting it to the original data, and we can do what we call by group analyses. So here, instead of bringing or running it only for Chicago, we could very easily say run a by group for every single origin airport. And what this will do is this will now run the same model, but it'll run it for different subsets of data, in this case, for each origin airport. Once we have built an analytic workflow, we can very easily deploy it to Statistica Enterprise with just a couple clicks. So here I'm deploying it as a new object in Statistica. And here again, you'll see that this is fully validated, meaning it keeps track of who makes what change when. And we can even assign user access permissions so that we know exactly who has access to what templates. The advantage of deploying these models to a centralized repository like Statistica Enterprise is that it now allows users to automate, schedule, and run on demand, and more importantly, monitor and manage all these different modeling templates. So let's say we want to do some champion challenger modeling. Here, for this particular data set, we know that the neural network seems to work the best. But before we push this to production, we need to know if this is better than the current champion. In order to do that, we can now bring in the champion model and compare it against the existing neural network model. Here you can see that we can just go in and load the PMML from the centralized repository. And here we have the champion, which is currently in production. And we are now going to compare that against the neural network model that we just created. So here we can see that the neural network model that we just built actually does better than the champion that is in production. So if we now want to push this model into production, we can very easily do that by going here and deploying this model into the centralized metadata repository, which is Statistica Enterprise, and updating an existing model, in this case, the champion. So we can now update that. But obviously, as I said, everything is validated and there's a very comprehensive audit control as well as a dynamic version control system behind the scenes. So it keeps track of all the changes that we make. Okay, while we are talking about champion challenger modeling, it's very important that we understand that there are various checks in place to make sure that unintended models do not make it into production. So that's exactly what we have here in this migration utility. And by the way, before we do that, I just wanted to show you the versions. So here you can actually go through all the different versions, identify how they're different, who made what change when, and you can look at different versions and you can compare them and so on. But as I was saying, once you have a champion in your development environment, which you think is the best model and you want to push it into production, we can use the migration utility where we can take any template, whether it's a data template or a dashboard template or an analysis template, and very easily push it into production with just a single click. But as I said, there are a lot of different options, such as only the latest approved versions can be transferred and so on. To summarize, we took the example dataset that was provided around airline delays, and we showed data access and how we can connect to multiple data sources, as well as we showed the geocoder node and how we can bring back the lat longs for further analytics and reporting. Then we talked about data pre-processing and data prep using the data blending and data transformations examples. We talked about how you can create new derived variables as well as use business logic using the rules engine and how you could also use that for conditional scoring logic. And then we talked about data exploration, specifically using the data health check node, which is what we call the one-stop shop for data understanding and pre-processing. And we also showed a visual drill down capabilities using the visualization dashboards. And then we talked about automated feature selection, model building, model evaluation, model security and governance, specifically around auditing and versioning using the document management system. And then we showed model management and champion challenger testing. So then we talked about how, if you have a champion and it has gone through the approval process, how you can migrate that to a production environment using a model migration utility. Apart from these examples, we also talked about the flexibility, extensibility, and openness of the platform, emphasizing on collective intelligence and how we can access multiple app marketplaces such as Algorithmia, Approbita, and Azure ML. Also, we talked about our integration with CNTK for deep learning. We then talked about the scalability and high performance computing capabilities using the H2O integration example. And then we talked about Statistica network analytics and how we can visualize and analyze the relationships and associations between multiple entities and actors. And finally, throughout this presentation, we've been talking about ease of use and how we can templatize and parameterize multiple analytic workflows and make it easier overall for the business user or the citizen data scientist to leverage the power of advanced analytics. Thank you.